Hi everyone, welcome back to my Itinerarium Chemistry YouTube channel. In Coordination Compounds Lecture 1, we have studied coordination compounds, ligands and their classification. In this video, we will start with definitions of some important terms. So we will see what is coordination entity. It constitutes a central metal atom to which fixed number of ligands are attached, which are enclosed in square brackets. First we will take an example, that is K4 FeCN6. Okay, this is the coordination compound. In this coordination compound, the iron is attached to 6 number of ligands. Okay, here iron is attached to 6 number of ligands. That is Cn, Cn, here Cn, Cn, here Cn and Cn. Okay, this is the central metal atom which is attached to 6 number of Cn ligands. Okay, which are enclosed in the square bracket. Therefore, this is called as coordination entity. Coordination entity. Okay. And next is the coordination entity which is enclosed in the square brackets is called as coordination sphere. Here, the coordination entity means the metal which is attached to fixed number of ligands, okay, which is enclosed in the square bracket, that is nothing but coordination entity. Here, the coordination entity is enclosed in the square bracket and that is called as coordination sphere. Okay, this coordination entity which is enclosed in the square bracket which is called as coordination sphere. Coordination sphere. Okay, the ion which is outside the coordination sphere is called as counter ion. Counter ion. The central metal atom which is attached to fixed number of ligands, okay, which are enclosed in the square bracket is called coordination entity. Okay, the coordination entity which is enclosed in square brackets is called as coordination sphere, and the ion which is outside the coordination sphere is called as counter ion. And coming to next one, that is central metal atom or ion. Okay, in coordination entity, the atom or ion to which fixed number of ligands are attached. For example, we will take nickel tetracarbonyl. Nickel tetracarbonyl. Okay, this is the coordination compound. So, in this coordination compound, if you write the structure, Ni, 4 CO ligands are present. CO, CO, here CO and CO. Here, 4 ligands are attached to a nickel, okay, which are enclosed in square brackets. Okay, we know that this is a coordination entity. So, here this nickel is the central metal atom which is attached to a fixed number of ligands. How many ligands are there? 4 ligands are there. Okay. Here the nickel is attached to 4 ligands. That means fixed number of ligands. Okay. Therefore, this is called as central metal atom. Central metal atom. Okay. We will take one more example, that is K4 FeCN6. Okay, this is the coordination compound. So, in this coordination compound, here iron is attached to 6 Cn ligands. Therefore, this iron is called as central metal atom. Central metal atom. Next one is coordination number. Here coordination number means number of donor atoms, okay, directly bonded to central metal atom. For example, consider CONH3 6 times, okay. Here charge is 3 plus. If you write the structure of this coordination compound, that will be cobalt is bonded to 6 NH3 ligands, right? 6 NH3 ligands. NH3, here NH3, NH3 and NH3. Okay. Here 6 ligands are attached to cobalt. So in this case, nitrogen is donor atom. Here nitrogen, here nitrogen, here nitrogen, nitrogen and nitrogen. How many donor atoms are attached to cobalt here? 6 donor atoms are there. Okay, 6 donor atoms are attached to the metal cobalt. Okay, so therefore the coordination number is 6. We will take one more example, that is CONH3 4Cl2. Again, this is also coordination compound. Here, cobalt is the central metal atom. How many donor atoms are attached? Here, 4 NH3 groups. That means 4 nitrogen will be there as donor atoms. And here, 2 Cl. That means 6 donor atoms are there. 6 donor atoms are there. Therefore, the coordination number is 6. Coordination number is 6. If you consider one more example, that is nickel tetracarbonyl. In this coordination compound, here nickel is the central metal atom to which 4 donor atoms are attached. Therefore, coordination number is equal to 4. Okay, this is how you have to identify the coordination number. Again, coordination number means number of donor atoms. Okay, number of donor atoms which are directly bonded to central metal atom or ion. Okay, that is nothing but coordination number. Next, we will see what is coordination polyhedron. Okay, the spatial arrangement of the ligands around the metal atom or ion which defines the geometry of the coordination compound. We will take an example. Again, we will take nickel tetracarbonyl. If you write the structure, here nickel, here CO, CO, here CO and here CO. In this coordination compound, the ligands around the central metal atom arranged in such a way that to give tetrahedral geometry. Okay, so in this case, the ligands are arranged in such a way that to give tetrahedral geometry. Okay, and we will take one more example, that is PtCl4 minus 2. Here platinum to which 4 ligands are attached, 4 Cl ligands are attached. Okay, this is the structure, right? Here minus 2. So here also we have 4 ligands and here also we have 4 ligands. But the difference is here the spatial arrangement of the ligands around the central metal atom in such a way that to give tetrahedral geometry, and here the spatial arrangement of the ligands around the central metal atom in such a way that to give square planar geometry. Okay, number of ligands in both the cases are same, but the spatial arrangement of the ligands around the metal is different, so that you are getting different geometries. So in this case we are getting tetrahedral geometry and here we are getting square planar geometry because of the spatial arrangement of the ligands around the metal. Okay, this is nothing but coordination polyhedron. Next one is oxidation number of central metal atom. It is defined as the charge it would carry if all the ligands are removed along the electron pairs that are shared with the central atom. Oxidation number of central metal atom or ion is calculated by the usual method, that is sum of oxidation number of all the atoms or groups in a molecule is equal to 0. We will take an example, that is K4 FeCN6. So we know that potassium will be having positive charge. Here Cn is anionic ligand, therefore it will be having negative charge on it. Okay. Now plus 1 charge on potassium into 4 because it is of 4 times. Okay. Plus what is the oxidation number of iron? That is what we are calculating. So that let it be X plus here Cn as minus 1 into 6. Okay. It should be equal to 0. 4 plus X plus minus 6 is equal to 0. X is equal to plus 6 minus 4. Therefore, X is equal to plus 2. Okay. Therefore, the oxidation number of iron is plus 2. This is how you have to calculate the oxidation number of the central metal atom. Let us take one more example, that is nickel tetracarbonyl. Okay, this is the coordination compound. We know that carbonyl is neutral ligand, so that the charge on the neutral ligand is 0. We are calculating oxidation number of nickel, so let it be X plus, what is the charge on the carbonyl ligand? It is 0 is equal to 0. X is equal to 0. Therefore, the oxidation number of nickel is 0. This is the neutral complex in which nickel has 0 oxidation number. This is how you have to calculate the oxidation number of central metal atom. Okay, let us know about what is homoleptic complex. Okay, the complex in which a metal is bound to only one kind of donor groups. For example, if you take nickel tetracarbonyl, okay, if you write the structure here, CO, here CO, CO and CO. Okay, this is the structure. In this structure, here nickel is attached to same kind of donor atoms. In all 4 ligands, okay, the donor atom is same. Therefore, it is homoleptic complex. Homoleptic complex. We will take one more example, that is CONH3 6 times. Okay, this is the coordination compound. In this compound, if you write the structure, okay, CO is the central metal atom to which 6 NH3 ligands are attached. Okay, here NH3, 6 NH3 ligands are attached. So, in all 6 ligands, nitrogen is the donor atom. Therefore, here the metal cobalt is bound to only one kind of donor atoms. Therefore, it is homoleptic complex. Okay. Next, coming to heteroleptic complex, the complex in which metal is bound to more than one kind of donor atoms. Okay. So, in homoleptic complex, only one kind of donor atoms are present. In heteroleptic complex, more than one kind of donor atoms are present. We will take an example, that is CONH3 Cl2. CONH3 4 times Cl2. This is the coordination compound. In this coordination compound, cobalt is the central metal atom. If you write the structure of this coordination compound, that is CO NH3 4 times, here NH3, here NH3 and here NH3, here Cl and Cl. Okay, this is the structure of the coordination compound. So, in this coordination compound, the cobalt is attached to 2 different donor atoms. Okay, in NH3 ligand, nitrogen is the donor atom, and in Cl ligand, Cl is the donor atom. That means here the cobalt is attached to 2 different donor atoms. Therefore, it is heteroleptic complex. We will take one more example. CONH3 4 times H2O and Cl. Okay, this is the coordination compound. So, cobalt is the central metal atom. In NH3, nitrogen is the donor atom. In H2O, oxygen is the donor atom. In Cl is the donor atom. That means here the cobalt is directly attached to 3 different types of donor atoms. Therefore, it is a heteroleptic complex. Now, we will look into nomenclature of coordination compounds according to IUPAC. Okay. The first point that you have to consider is the name of the cation is written first, followed by the anion. That means the name of the cation should be written first. If you take the coordination compound, that is K4 FeCN6. Okay. So, we know that potassium will be having positive charge. The charge of the cation is balanced by the charge of anion. Okay. Now, which is the cation? Potassium is the cation, so that the name of the cation should be written first. Okay. So that you have to write potassium first. Okay. Next point is the ligands are named in an alphabetical order before the central metal atom. Names of anionic ligands end with O. This we have discussed in anionic ligands, that is For example, if there is Cn minus ligand, okay, the name of this ligand should end with O. Therefore, it is named as cyanido. Cyanido. If Cl minus is there, this is named as chlorido. Chlorido. Okay, like this, the name of the anionic ligands end with O. Okay. Next is the name of neutral and cationic ligands named same as the element except H2O, CO, NO and NH3. Okay. And these are named as aqua. This is carbonyl. This is named as nitrosyl. And here NH3 is named as amine. Okay. Except these, remaining neutral and cationic ligands named same as the element. And next point is prefixes like mono, di, tri, tetra, etc. are used to indicate number of individual ligands in the coordination entity. Okay, if the ligand itself contains the prefix di, tri, tetra, then its number is indicated by the prefixes bis, tris, tetrakis are used. For example, consider you have Cl2. We know that this is an anionic ligand, so that the name of this anionic ligand should ends with O. Here, 2 Cl minus are present, therefore it is named as dichlorido. Dichlorido. Okay. If there is H2O 4 times, okay, we know that H2O is a neutral ligand which is named as aqua. Here, 4 H2O ligands are there, therefore it is named as tetra aqua. Tetra aqua. For example, ethane 1,2-diamine is there. Okay, ethane 1,2-diamine. It is a ligand. Okay. So here, this ligand itself contains a prefix di. 2-ethane 1,2-diamine ligands are present. Therefore, here the prefix bis is used. Okay. So that the name will be bis-ethane 1,2-diamine. Okay, this is how we have to name. For example, ethane 1,2-diamine. If you consider 3 ethane 1,2-diamine ligands are present, then it is named as tris ethane 1,2-diamine. Okay, 1,2-diamine. Okay, this is how you have to name. Okay, the prefixes like mono, di, tri, tetra, etc. are used to indicate the number of individual ligands. Okay, if the ligand itself contains prefix like di, tri, tetra, then the number is indicated by using the prefixes like bis, tris, tetrakis. Okay. Next rule is, if the complex ion is cationic or neutral, the metal is named same as the element. Okay. For example, let me take nickel tetracarbonyl. First, we have to name the cation. Here, there is no cation. Therefore, we have to start with the coordination entity. In that, first we have to start with the ligand. How many ligands are there? 4 ligands are there. Therefore, what is the prefix that we have to use? Tetra. Okay. This is a carbonyl ligand. Therefore, it is tetracarbonyl. Now, while writing the name of the metal, okay, since this is a neutral complex, here the name of the metal should be named as the element. Okay, therefore, it is tetracarbonyl nickel. Tetracarbonyl nickel. This is how you have to name. Okay, if the complex is anionic, the name of the metal ends with the suffix ate. For example, again we will take K4 FeCN6. Okay, here potassium will be having positive charge and here we will be having negative charge because charge on the cation is balanced by charge on anion. Here it is plus 4 because 4 K plus are there. Okay, and here it will be minus 4. This is anionic complex. Okay, because the negative charge is present on the coordination sphere, therefore it is anionic complex. Now, according to the set of rules we have studied, cation should be named first. Therefore, potassium, and then we have to write the name of the ligands. How many CN ligands are there? 6 ligands. Therefore, the prefix hexa is used. Okay, hexacyanido, okay. And next, the fourth rule says that, okay, if the complex is anionic, okay, this is an anionic complex, the name of the metal ends with the suffix ate, okay. Since it is an anionic complex, here the name of the metal should ends with suffix ate. Therefore, it is written as ferrate, okay, ferrate. Okay, this is how you have to write. Therefore, if the complex is anionic, the name of the metal should ends with the suffix ate, okay, ate. Fifth rule says that the oxidation state of the metal is denoted by Roman numeral in brackets. Okay, we will take the same example, that is K4 FeCN6. So here +4 and here -4. What is the oxidation state of iron here? It is +2, just now we calculated. Now, while writing the name of the coordination compound, cation should be named first. Yes, therefore potassium. Okay, then we have to write name of the ligand. How many ligands are there here? 6 ligands. 6 CN ligands are there. Therefore, it is hexacyanido. Since this is a anionic complex, the name of the metal should ends with the suffix ate. Therefore, it is ferrate. And the fifth rule says that the oxidation state of the central metal is denoted by Roman numeral in brackets. What is the oxidation state of iron here? +2. So that you have to write it by Roman number 2 and it has to be enclosed in brackets. Okay. Here this is potassium hexacyanido ferrate 2. Okay. Next, sixth rule says that there should be no space between the ligands and the metal within the coordination sphere. This is the coordination sphere. While writing the name of the coordination sphere, there should be no space between ligand and metal. Okay, it should be like one word. Okay, this is the coordination sphere, right? Okay, you should not give any space. You have to give only one space between counter ion and coordination sphere. Now, we will see the name of neutral ligands. Here, the neutral ligands will be having no charge, therefore, they are called as neutral ligands. Okay, here this naming is according to IUPAC nomenclature. Okay, the first one is H2O, which is a neutral ligand, which is named as aqua. And second one, NH3, which is named as amine. Here, double M is there. Okay, remember that. And coming to next one, CO, which is named as carbonyl. NO is named as nitrosyl. And CH3NH2, which is named as methylamine. Okay, methylamine. Next one, here NH2CH2CH2NH2, okay, which is named as ethane 1,2-diamine, which can also be written by denoting En. Okay, En means ethane 1,2-diamine. Next, coming to C5H5N, that means pyridine. The structure of pyridine is this one. Okay. Next one is S8, which is named as octasulfur. And coming to here PPH3, if you write the structure of PPH3, that is triphenyl phosphine. Here phosphorus, which is attached to 3 phenyl groups. 3 phenyl groups. So here phosphorus will be having lone pair of electrons and this lone pair of electrons are donated to metal atom. Therefore, phosphorus is the donor atom. Okay, it is named as triphenyl phosphine. Next one is bipyridine. This is the structure of bipyridine, which is named as 2,2-bipyridyl. Next one is C2H4, which can be written as CH2 double bond CH2, which is named as ethylene or ethene. Okay, next one is orthophenanthroline. This is the structure of orthophenanthroline. Here, 2 nitrogen atoms are the donor atoms. Okay, which is named as orthophenanthroline. Next one is NH2C double bond O NH2, which is named as urea. And next one is O2, which is named as dioxygen. And next one is P4, which is named as tetraphosphorus. And next one is C6H6, which is named as benzene. And here NH2OH, which is named as hydroxylamine. Here only one M is there. This is amine, and coming to here, this is amine. Candidates who are preparing for Karnataka board exam, this will be enough for them. But the candidates who are preparing for NEET, JEE mains and advanced, you have to go through all of this. Next we will see name of anionic ligands. While naming anionic ligands, the name of anionic ligand should ends with O. Now we will see here OH minus is there. It is not hydroxide. Instead of that, it is named as hydroxido. Okay, here H minus, it is not hydride. Okay, it is named as hydrido. Okay, here X minus is there. That means halogens. Therefore, it is named as halido. If F minus is there here, it is named as fluorido. If Cl minus is there, it is named as chlorido. If Br minus is there, it is named as bromido. If I minus is there, it is named as iodido. Next one is Cn minus, so which is named as cyanido or cyanido C. That means here C is the donor atom. Coming to Nc minus, this is named as isocyanido, okay, which can also be named as cyanido N. Here nitrogen is the donor atom. Coming to N3 minus, okay, the charge is 3 minus, don't get confused. Here N3 minus, which is named as nitrido. Coming to next one, that is N3 minus, here charge is -1 and here charge is -3. You should not get confused between these two. Okay, if N3 minus is the charge, which is named as nitrido. If N3 -1 is the charge, which is named as azido. Okay, next is NH2 minus. NH2 minus is named as amido. Coming to next one, here NH2 minus, here charge is 2 minus and here charge is 1 minus. You should not get confused between these two. Okay, here NH2 minus is named as imido. And next one is SO4 2 minus. Okay, SO4 2 minus is named as sulfato and SO3 2 minus is named as sulfito. Here HSO3 minus, here charge is -1, which is named as hydrogen sulfito. Next one is NO2 minus, here charge is -1, which is named as
nitrito N, because here the donor atom is nitrogen.
Coming to ONO minus, it is named as
Nitrito O, here oxygen is donor atom.
Next is SCN minus, which is named as thiocyanito N. Thiocyanito N. Here N is because of nitrogen is the donor atom. And coming to NCS minus, which is named as thiocyanito S. Here sulfur is the donor atom. Next one is HO2 minus, which you can also write like this, HOO minus. Okay, here it is H2O2, whereas H is removed, therefore oxygen will be having negative charge, which is named as hydrogen peroxido. And next one is C2O42 minus. If you write the structure of C2O42 minus, this is the structure which is oxalate ion, which can be named as oxalato. Okay. Next is NH2CH2COO minus, which is named as glycinato. And next one is CH3C double bond NO minus. And here CH3C double bond NO minus, here these two carbon atoms are attached, which is named as dimethyl glyoxymeto. Okay. And coming to next one, here CH3 C double bond O, CH double bond, C single bond O minus, CH3, which is named as acetyl acetonato, which can also be written like this, ACAC. Okay. If you see anywhere ACAC, that means the ligand is acetyl acetonato. Next we will see about ethylene diamine tetraacetate, okay, which is also anionic ligand. If you consider EDTA 4 minus, the name of this ligand is ethylene diamine tetraacetate. Okay, this is the name of the ligand. If you write the structure of ADTA, okay, here nitrogen, CH2, CH2, nitrogen, here you will be having CH2 COO minus, CH2 COO minus, and here CH2 COO minus, and here also CH2 COO minus. Okay, here 4 negative charge, and along with that nitrogen will be having lone pair on it. Therefore, it is an example for hexadentate ligand. Hexadentate ligand. This ADTA can also be pentadentate ligand. If you write the structure of that means nitrogen, CH2, CH2, here nitrogen, here hydrogen, and here CH2 COO minus. Okay, here also CH2 COO minus, here also CH2 COO minus. Here 3 negative charge plus 2 lone pair of nitrogen atoms. Okay, therefore it is an example for pentadentate ligand. Pentadentate ligand. Okay, because 5 donor atoms are there. If we take diene, okay, here diene means diethylene triamine, diethylene triamine. Okay, if you write the structure here NH2, CH2, CH2, NH, CH2, CH2, NH2. Okay, how many donor atoms are there in this ligand? Here nitrogen will be having lone pair of electron. Here also nitrogen will be having lone pair of electron. And here also nitrogen will be having lone pair of electrons. Therefore, 3 donors are there. Therefore, it acts as tridentate ligand. If we consider triene, triene means triethylene tetramine. Okay, tetramine. We will write the structure of triethylene tetramine, that is here NH2, CH2, CH2, NH, CH2, here CH2, and here NH, again CH2, CH2, NH2. Okay, this is the structure of triethylene tetramine. How many donor atoms are there here? Here nitrogen is there, here nitrogen, and here nitrogen. 4 donor atoms are there. Okay, therefore it is an example for tetradentate ligand. Tetradentate ligand. Now we will look into name of cationic ligands. Okay, here NO plus is named as nitrosonium. Next one is NO2 plus. Here also charge is +1 and here also charge is +1. But the difference is here 2 oxygens are there. Here only 1 oxygen. You should not get confused between these two. Here NO2 plus is named as nitronium ion. NH4 plus is named as ammonium, and NH3 plus NH2 is named as hydrazinium. Let us start naming this coordination compound. Before that, we will calculate oxidation number of the central metal atom, that is chromium. Oxidation number can be calculated by using 2 methods. First one is sum of oxidation number of all the atoms in the molecule should be equal to 0. Okay, we will see that. Here we don't know the oxidation number of chromium, so that let it be X plus how many NH3 ligands are there? 3 ligands are there. 3 into what is the charge on NH3? It is a neutral ligand, therefore the charge is 0. Okay, plus here how many H2O ligands are there? 3 ligands into what is the charge on H2O? It is a neutral ligand, therefore it is 0. Plus here each Cl will be having charge -1. -1 into 3, therefore -3. Okay, should be equal to 0. Okay, therefore X is equal to +3. Okay, the oxidation state of chromium is +3. We can also calculate the oxidation number by separating the coordination pair. Okay, as I said earlier, each Cl will be having charge -1. So -1 into 3, minus 3. Okay, here total charge will be minus 3. We know that charge of cation should be balanced by charge of anion. Therefore, the charge on the coordination sphere should be plus 3. Okay, now we will separately calculate the oxidation number of chromium using only coordination sphere. That is, let the oxidation number of chromium be x. Okay, x plus again 3 into 0 because NH3 is a neutral ligand plus again H2O is a neutral ligand. Therefore, the charge is 0. Again 3 into 0, which should be equal to charge on the coordination sphere, that is plus 3. Okay, if you calculate now, what will be the x value now? X is equal to plus 3. Okay, so you can calculate oxidation number by these two methods. The answer will be same. Okay, the answer will be same. Here also plus 3 and here also plus 3. Okay, let us start writing the name of the coordination compound. Here we know that cation should be named first. Okay, which is the cation among these two? Here, this coordination sphere is the cation. Therefore, name of this cation should be written first. Okay, in that we have to start writing the name of ligands according to the alphabetical order. Here, this ligand is amine and here this is aqua. Which comes first according to alphabetical order? Amine comes first. Okay, if you write amine and if you write aqua. Okay, here A and A common. The second letter is here M and here Q. M comes first, therefore you have to write amine first. Okay, therefore triamine. Okay, how many H2O ligands are there? 3. Therefore again prefix tri is used. Okay, triamine, triaqua. Here this is the cationic complex. Therefore the name of the metal should be written as the name of element. Therefore it is cobalt. What is the oxidation number of cobalt here? Plus 3. Just now we calculated, right? Plus 3. Okay, and then space, and then you have to write the counter ion, that is chloride. Okay, here you should not add any prefixes like di, tri, tetra because it is a counter ion. While writing the name of coordination compounds, there should not be any space between ligands and metal which are present in the coordination sphere. It should be like one word. Okay, we have set of rules to write the name of coordination compounds that we have studied now. Here first you have to calculate the oxidation number. What is the oxidation number of copper here? Okay, let it be X plus Br is an anionic ligand which is having charge minus 1. Minus 1 into 4. Minus 1 into 4. Okay, that should be equal to charge on the coordination sphere. What is the charge on the coordination sphere? That is minus 2. Now X is equal to minus 2 plus 4. Therefore, X is equal to plus 2. What is the oxidation state of copper in this complex? That is plus 2. Okay. Now we will start writing name of this coordination compound. First we have to write the name of cation. Okay. Here we have only anionic complex. Okay. Therefore, we have to start writing with the name of ligand. How many ligands are there here? 4 ligands. Therefore, the prefix tetra is used. Tetrabromido. Here, this is an anionic complex. Okay, therefore, the name of the metal should end with ATE. Okay, ATE. Therefore, it is cuprate. What is the oxidation number here? That is 2. Therefore, tetrabromido cuprate 2 ion. Okay, here we have only anionic complex. Therefore, you have to write ion here. This is the name of the coordination compound. So here we have another example. First we will calculate the oxidation number of nickel, that is, let it be X plus, we know that CO is a neutral ligand, therefore the charge in the neutral ligand is 0. Okay, that is 0 into 4 should be equal to 0 because here the complex has no charge. Therefore, X is equal to 0. Here the oxidation number of nickel is 0. Okay, we will start writing the name. How many ligands are there here? 4 ligands. Therefore, again prefix tetra, carbonyl, Okay, you have to write the name of the metal as the name of element. Tetracarbonyl, nickel. What is the oxidation state here? 0. This is the name of coordination compound. Here is the next example. We know that the potassium will be having positive charge on it. Therefore, 2 potassium ions are there. Therefore, the charge will be plus 2. And we know that the charge of cation should be balanced by the charge of anion. Therefore, the charge on the coordination sphere will be minus 2. Now, we will calculate the oxidation number of zinc by separating the coordination sphere. Oxidation number of zinc Bx plus, we know that this OH will be having the charge minus 1. Okay, minus 1 into 4, that is minus 4, should be equal to the charge on the coordination sphere, that is minus 2. Therefore, X is equal to plus 2. You can also calculate the oxidation number of zinc by another way, that is, sum of oxidation number of all the atoms or groups in the molecule is equal to 0. We will calculate oxidation number by using this method also. We will check, okay. Let the oxidation number of zinc be X plus, your OH will be having 1 minus charge, 1 minus into 4, therefore 4 minus plus, here potassium will be having plus 2 charge, therefore plus 2 should be equal to 0. Okay, now X is equal to plus 2. You can calculate the oxidation number by using both the methods, but the answer will be same. Okay, let us write the name of coordination compound. Here we have to write the cation first. Which is the cation here? Potassium is the cation. Therefore, potassium, we have to give one space here because there should be space between counter ion and the coordination sphere. Okay, now we have to write the name of ligand. How many ligands are there? 4 ligands. Therefore, tetrahydroxido. Okay, since the complex is anionic complex, the name of the metal should end with ATE. Therefore, it is zincate. Zincate. What is the oxidation number of zinc here? That is plus 2. Zinc 2. Okay. This is the next example. Now we will start writing the name of this coordination compound. Before that, we will calculate the oxidation number of cobalt here. Okay. So coming to here, we know that SO4 will be having minus 2 charge, right? Minus 2 into 3 times, therefore it will be minus 6. Okay. And what is the charge on the coordination sphere? That will be plus 6. Because we know that charge on the cation should be balanced by charge on anion. Okay. So now we will calculate oxidation number of cobalt. Let it be X plus. Here, what is the charge on ethane 1,2-diamine ligand? It's a neutral ligand, therefore the charge is 0. X plus 0 is equal to plus 6. Okay, plus 6. Therefore, X is equal to plus 6. But here, coordination sphere is of 2 times. Therefore, it has to be divided by 2. Therefore, X is equal to plus 3. Okay, here the oxidation number of cobalt is plus 3. Now we will start writing the name. We know that according to the set of rules, cation should be named first. Okay. Here ethane 1,2-diamine ligand, which already has the prefix di, therefore we have to go for the prefix tris because here 3 times of ethane 1,2-diamine ligand is present. Okay. Therefore, tris ethane 1,2-diamine, ethane 1,2-diamine. Now you have to write name of the metal. Okay, since it is a cationic complex, the name of the metal should be written as the name of element. Therefore, it is cobalt. Cobalt. What is the oxidation number of cobalt here? Plus 3. What is the counter ion here? Sulfate. Sulfate. Okay, the name is tris ethane 1,2-diamine cobalt 3 sulfate. This is the next example. In this type of complexes, Ag will be having, okay, Ag will be having plus 1 charge. If you write plus 1 charge here, what happens? Here plus 1. And we know that NH3 is a neutral ligand, therefore the charge is 0. Therefore, what is the charge on the coordination sphere? Plus 1. Here also, if you write plus 1 again, we know that Cn is an anionic ligand, which will be having minus 1 charge. Okay, minus 1 into 2, gives minus 2. Okay, what is plus 1 minus 2? That is minus 1. Among these two coordinations pair, we have to write the cationic complex. In that, we have to write the name of the ligand. How many ligands are there? 2 ligands. Therefore, what is the prefix? Diamine. Diamine. Okay. Here, this is the cationic complex. Therefore, the name of the cation should be written same as the element. Therefore, silver. What is the oxidation state of silver? That is plus 1. Okay. Then you have to give one space and then you have to write the name of anion. And here also you have to start with the ligand. How many ligands are there? 2 CN ligands are there. Therefore, it is dicyanide. Dicyanide. This is anionic complex. Therefore, it is argentate. Argentate. What is the oxidation state here? That is plus 1. Okay. This is the name of the coordination compound. Coming to next example. So first we will calculate the oxidation number of cobalt. Here Cl will be having minus 1 charge. Therefore minus 1 into 2, it will be minus 2. And the charge on the coordination pair will be plus 2. Okay, now what is the charge on NH3 ligand? 0. Here what is the charge on H2O ligand? That is also 0 because these two are neutral ligands. Then coming to Cl, what is the charge? That is minus 1. Okay, minus 1. Now we will calculate the oxidation number of cobalt here. Let it be X plus 0 plus 0, right? Plus minus 1 should be equal to plus 2. Therefore, X is equal to plus 3. Here what is the oxidation state of cobalt? That is plus 3. Now we will start naming. The cation should be named first. Here we have ligands amine and aqua. So among these two, amine comes first according to alphabetical order. Therefore, how many amine ligands are there? 4. The prefix is tetra. Okay, tetra amine. Tetra amine. Then comes aqua. Aqua. Then comes chlorido. Chlorido. Since it is a cationic complex, you have to name the metal as cobalt. Cobalt. What is the oxidation state of cobalt here? Plus 3. Give space and then you have to write the counter ion, which is chloride. Okay, chloride. That is tetraamine aqua chlorido cobalt 3 chloride. Coming to next example, here potassium will be having plus 1 charge. Therefore, plus 1 into 3, it is plus 3. And the charge on the coordination pair will be minus 3. So we know that this is an oxalato ligand, COO minus and COO minus. In the ligand oxalato, 2 negative charges are there. Therefore, minus 2 into 3, it gives minus 6. Okay, now I will find out the oxidation number of aluminium here. So let it be X plus minus 6 is the charge on 3 oxalato ligands, which should be equal to minus 3. Okay, this is the charge on the coordination pair. Therefore, X is equal to plus 3. The oxidation number of aluminium is plus 3. Now we will start writing the name. First we have to write the cation. Therefore, we have to write potassium. Potassium space. Next we have to write the name of the coordination pair. Here we have to start with the oxalato ligand. How many oxalato ligands are there? 3 oxalato ligands. Therefore, the prefix tri is used. Okay, trioxalato. Trioxalato. Since it is an anionic complex, therefore it is aluminate. Aluminate. What is the oxidation number? It is plus 3. Okay. Therefore, it is potassium trioxalato aluminate 3. Coming to next example. Here the charge on the amine ligand is 0. And here charge on Cl is minus 1. Charge on NO2 is minus 1. Okay. Now, we will calculate the oxidation number of platinum, that is X plus, okay, 0, minus 1, again minus 1 should be equal to 0. Therefore, X is equal to plus 2. Okay, here the oxidation number of platinum is plus 2. Now we will start writing the name of the coordination compound. In this case, we have to write the name of the ligands first according to the alphabetical order. First comes amine and then chlorido and then nitrito, right? Therefore, how many amine ligands are there? 2 amine ligands. Therefore, it is diamine. Next is chlorido, nitrito, N. If there is ONO minus, it is nitrito O. Here it is nitrito N. Since there is no charge on the complex, the name of the metal should be written as the name of the element. Therefore, it is platinum. Oxidation state is plus 2. Coming to next example, we know that the charge on the Cl will be minus 1. Therefore, the charge on the coordination sphere will be plus 1. Now, the charge on H2O ligand is 0 because it is a neutral ligand. Coming to Cl, it will be having minus 1 charge, minus 1 into 2, minus 2. Okay, now we will calculate the oxidation number. The oxidation number of chromium will be X, okay, plus 0 plus minus 2 should be equal to plus 1. Therefore, X is equal to plus 3. The oxidation number of chromium is plus 3. So, according to the set of rules, we have to write the cation first. So that we have to write the name of cationic complex first. In that, we have to start with the ligands according to the alphabetical order. Therefore, here aqua comes first. 4 H2O ligands are there. Therefore, the prefix tetra is used. Okay, tetra aqua, dichlorido. Okay, chromium. What is the oxidation state? That is plus 3. Okay, plus 3. Give space while writing the counter ion. That is chloride. Here 2H2O is there. Okay, so that can be written as dihydrate. Okay, dihydrate because 2 H2O molecules are there. In some books, it is also given as 2 water. Both are correct. Okay, so the name is tetra aqua dichlorido chromium 3 chloride dihydrate or 2 water. Both are correct. Here the charge on Hg will be plus 1. Therefore, the coordination sphere will be having minus 1 charge. Okay, we know that SCN is an anionic ligand which will be having minus 1 charge. Therefore, minus 1 into 4, it is minus 4. Now, we will calculate the oxidation state of cobalt. Let it be X plus minus 4 should be equal to minus 1. Therefore, X is equal to plus 3. Okay. So, here we have to write the name of the cation first. So, we have to write the cation Hg, which is a d block element. Therefore, it is mercury. Here you have to make a note that if d block elements or counter ions, okay, then you have to write the oxidation state. What is the oxidation state of mercury here? It is plus 1. Therefore, you have to write 1 and then you have to give space to write the coordination sphere. So, here how many SCN ligands are there? 4. Therefore, the prefix tetra is used. Tetra thiocyaneto. Here it is a anionic complex. Therefore, the name of the metal should ends with ATE, cobaltate. Oxidation number of cobalt is plus 3. Okay, 3. The name is mercury 1 tetrathiocyanato cobaltate 3. Now we will start writing the name of some special complexes. So here we have a bridging ligand. Okay, here 2 OH ligands are acting as bridging ligands. Okay, first we will calculate the oxidation state of 2 metal ions. Okay, so we know that oxalato ligand will be having minus 2 charge. So therefore minus 2 into 2 it is minus 4 and here also minus 2 into 2 it is minus 4. Okay, So first we will write that here two metal ions are there, therefore it will be 2x, okay, plus charge on the oxalato ligands are -4, again -4, plus, and here OH will be having -1 charge, therefore -1 into 2 it is -2, okay. Here -2 should be equal to -4, therefore 2x is equal to +6 and x is equal to +3, okay. The charge on the each metal ion will be +3, okay. Now we will start writing the name. So in this case we have a bridging ligand, therefore the name of the bridging ligand should be written first, okay. And we know that bridging ligands are denoted by the symbol mu. How many hydroxido ligands are there here? Two hydroxido ligands, therefore mu dihydroxido, dihydroxido. Here we have chromium and C2OH4 twice, and here also we have chromium C2O4 twice. Therefore, the special prefix bis is used. Bis is used. Next, we have to write the name of the ligand. How many ligands are there? Here two ligands and here two ligands. Therefore, we have already used the prefix bis. Therefore, you have to write now dioxalato. Dioxalato. Since the complex is anionic complex, therefore the name of the metal should ends with ATE. Therefore, it is dioxalato chromate 3, okay. The name is mu dihydroxido bis dioxalato chromate 3, okay. Coming to next example, here also we have two bridging ligands, one is OH and another one is NH2, okay. So here SO4 will be having -2 charge, -2 into 2 it is -4, therefore the charge on the coordination pair will be +4, okay. And we know that aqua is a neutral ligand, therefore charge is 0. Here also amine is a neutral ligand, therefore charge is 0. Now OH is a anionic ligand, therefore charge is -1, and NH2 is a anionic ligand, therefore the charge is -1, okay. Here we have two cobalt metal ions, therefore the oxidation state of two cobalt ions will be 2x, okay, plus here we have -1 and here also we have -1, therefore it is -2 is equal to +4, therefore 2x is equal to +6 and x is equal to +3. Charge on the each cobalt will be +3, okay. Now we will start writing the name. In this type of complexes, the bridging ligands are named first. Here we have two different bridging ligands, one is hydroxido and here NH2. Here also these two bridging ligands are named according to the alphabetical order, therefore amido comes first, okay. Okay, mu amido, mu hydroxido, mu hydroxido. In this complex, here cobalt is attached to NH3 4 times and here cobalt is attached to H2O 4 times. Okay, we will write these two separately. First, we will start with cobalt H2O 4 times. That is, here 4 H2O ligands are there. Therefore, the prefix tetra is used. Okay, it is tetra aqua cobalt 3. Now you have to write the name of NH3 ligand and cobalt. Okay, how many NH3 ligands are there? 4. Therefore again tetraamine cobalt 3. Okay, here we have the counter ion sulfate. You have to give space and then you have to write sulfate. Mu amido, mu hydroxido, tetra aqua, cobalt 3, tetraamine, cobalt 3, sulfate. Now we will discuss about hapticity. Okay, hapticity. Okay, which is denoted by the symbol eta. Okay, this is eta. So here hapticity means the term used. Okay, this is the term used to describe the participation of multiple multiple donor atoms, multiple donor atoms simultaneously during the pi coordination, during the pi coordination. Okay, so we will see what it is. Here the apticity is denoted by the symbol eta to the power x. Here x means number of donor atoms of the ligand, number of donor atoms of the ligand, donor atoms of the ligand. Okay, for example, here we have carbon atom, here also we have carbon atom, and here also we have carbon atom. So what happens in this case? Here this carbon atom will also act as a donor atom. These two carbon atoms will also act as donor atoms by donating this pi electrons, okay, to the metal atom. Therefore here the apticity is eta 3 because we have 3 donor atoms, okay. This is carbon atom and this carbon atom and this carbon atom. All 3 carbon atoms will acting as a donor atoms. We will take one more example, that is C5H5 minus. If you write the structure will be like this. Okay. Here negative charge. It is named as cyclopentadienyl. Okay. Which can also be written as like this. Okay. Here negative charge. Okay. The name of this compound is cyclopentadienyl. Cyclopentadienyl. Okay, cyclopentadienyl. Now we will consider a compound which is Fe eta 5 C5H5 two times. Okay, so here two cyclopentadienyls are there. Here the donor atoms are 5, therefore it is eta 5. If we write the structure of this compound, okay, it will be like this. Okay, here negative charge. Okay, and here we have another cyclopentadienyl anion, here also negative charge, and here these two negative charges are being donated to the metal iron. Okay, so this is the structure of the compound which is called as ferrocene. Okay, the name of the compound is ferrocene. Here this compound is also called as sandwich compound. Okay, because here the metal is sandwiched between two cyclopentadienyl anions. Okay, now if you write the name of the compound according to the IUPAC nomenclature, here iron is the metal, here we have cyclopentadienyl ligands. Here the name of the ligand itself contains the prefix di, therefore we have to go for the special prefixes, that is bis, because two cyclopentadienyls are there. Okay, therefore bis cyclopentadienyl, what is the name of the metal? Iron. What is the oxidation state of metal here? We know that each cyclopentadienyl anion will be having negative charge. Here we have 2 cyclopentadienyl, therefore it is -2 should be equal to 0, therefore x is equal to +2. Therefore the oxidation state of iron is +2, you have to write 2. Okay, the name is bis cyclopentadienyl iron 2. We will take another example, that is Cr eta 6 C6 and H6 two times. Okay, now if you calculate the oxidation state of chromium, here this C6H6 will be having 0 charge. Okay, therefore x plus 0 should be equal to 0. Therefore oxidation number of chromium will be 0. Now we will start writing the name. Here the ligands are named first. How many ligands are there? 2. Therefore the prefix di. C6H6 is a benzene, right? Therefore it is dibenzene chromium. Oxidation state of chromium is 0. So therefore the name is dibenzene chromium. If you write the structure, that is, here we have a benzene ring. Okay, and here also we have benzene ring. Okay, here the pi electrons are being donated to chromium. Okay, this is also sandwich compound, sandwich compound, because the chromium is sandwiched between two benzenes. In this case, eta is 6, that is apticity is 6, because here all 6 carbon atoms are acting as the donor atoms. Okay. Next we will move on to Zeiss salt, that is platinum Cl3 eta 2 C2H4. Okay. So this is the Zeiss salt. The charge on the complex is -1. Okay. Now we will calculate the oxidation number of platinum. We know that Cl will be having -1 charge. -1 into 3, it is -3. Here the charge is 0. Therefore, x plus, okay, -3 should be equal to -1. Therefore, x is equal to +2. The charge on the platinum in Zeiss salt is +2. Here this eta 2 C2H4 can be written as like this. Okay, that is CH2 double bond CH2. Here the pi electrons of these two carbon atoms are being donated to the metal ion. Therefore, here the apticity is 2, because here two carbon atoms are acting as donor atoms, which is called as ethylene. Okay, ethylene or ethene. Ethene. Okay. Now we will start writing the name of this Zeiss salt. That is, first we have to write the name of the ligands. According to alphabetical order, chlorido ligand comes first. How many chlorido ligands are there? 3. Therefore, the prefix trichlorido. Here C2H4 is named as ethylene. Okay, ethylene. Since the complex is an anionic complex, the name of the metal should ends with ATE. Therefore, it is platinate. Oxidation state is +2. Therefore, here 2. Ion. Trichlorido, ethylene, platinate, 2 ion. Okay. Now, we will write the formula for the given coordination compounds. So far, we have studied how to write the IUPAC nomenclature. But now, IUPAC nomenclature of the coordination compound is given. Now, we have to write the formula of the coordination compound. To write the formula of the coordination compounds, so you have to remember the simple order. That is, first you have to write name of the simple cation. Then you have to write name of the central metal atom. Okay, and then you have to write name of the ligands. Okay, and then you have to write simple anion. Okay, this is the order you have to follow. Let us start with the examples that we have taken here. First, you have to write the simple cation. So in the first example, we have no simple cation. Okay, because this is the cationic complex, and here this is counter ion which has a negative charge. We have no simple cation here. So what we have to write next? Next, we have to write the name of the central metal atom, which is the central metal atom here. So this is penta aqua chlorido chromium 2. The central metal atom is chromium. Okay, then you have to write the name of the ligands. We have penta aqua. That means aqua means H2O. Penta means 5 times. Then we have chlorido, only 1 Cl. Okay, close the brackets, and then you have to write the counter ion, which is chloride. Okay, now you have to cross check with the oxidation number. Here the oxidation number of chromium is given, that is +2. Okay, +2, and the charge on H2O ligand is 0. Cl will be having -1 charge. Now we have to find out the charge on the coordination sphere. That is, here +2 -1 gives +1. Okay, the charge on the coordination sphere is +1. The charge on the counter ion -1. Therefore, the formula is Cr H2O 5 times Cl. Okay, Cl. Therefore, this is the formula. Okay. Coming to second example, here tetraamine platinum 2 and tetrachlorido platinate 2. First we have to write the simple cation. So now how we are going to find out the simple cation here? We know that, so if there is an anionic complex, the name of the metal should ends with ATE. Therefore, this is an anionic complex. It is cationic complex. Okay, first we will write the cationic complex. In that we have to write the metal first, that is platinum. Okay, how many ligands are there? Tetraamine. Okay, NH3 ligands, NH3 4 times because it is tetraamine. Okay, now you have to write the complex anion. So here the metal is again platinum. Okay, and how many ligands are there? 4 ligands. The ligand is chlorido, therefore it is Cl4, close the square bracket. So now you have to check with the oxidation number which is given. Okay, so here it is given that it is a +2 and here it is given that +2. But here it is mentioned that platinate, therefore it is understood that this is an anionic complex. Here the negative charge is there, here the positive charge is there. Okay, now we have to cross check again. So here we have Cl4, that means each Cl will be having one negative charge, therefore -1 into 4, it is -4. Okay, here the sum of +2 minus 4 is what? -2. Okay, therefore the charge on the coordination sphere is -2. Here the charge on the coordination sphere is 0 plus 2, therefore it is +2. Therefore platinum NH3 4 times and here Pt Cl4 -2 and here +2. Okay, this is the formula of the coordination compound. So coming to next example, we know that first we have to write the simple cation and the coordination sphere. So first we have to write the simple cation, that is iron. Okay, therefore Fe. Next we have to write the central metal atom. Here that is ferrate 2. Here ferrate indicates that it is an anionic complex. Therefore Fe. How many cyanido ligands are there? Hexacyanido, therefore it is 6 Cn minus ligands are there. Okay, here the oxidation state of the iron is +2. Okay, it is given. Now we will find out the charge on the coordination sphere. Okay, here we have Cn ligands which has -1 charge, -1 into 6, it is -6. Okay, here +2 minus 6 gives -4, but here it is already given that the charge of iron is +3. So what you have to do? Now you have to balance in such a way that the charge on the cation should be equal to the charge on the anion. Therefore, what you will do in order to balance, here Fe4, here the complex is of 3 times. Now the charge of the cation will be equal to the charge of the anion. Therefore, this is the formula. So if you write it again, it will be Fe4, FeCN6, FeCN6, 3 times. This will be the formula. Okay, +3 into 4, it is +12, and here -4 into 3, it is -12. Therefore the charge on the cation is balanced with the charge on the anion. Coming to next example, again here also we have to write the simple cation first, then central metal atom, then you have to write the ligands, and then you have to write the simple anion. Here it is given that nitrate. Okay, this is the coordination sphere, dichlorido bis ethane 1,2-diamine, platinum 4, and there is a space, and then it is given that nitrate. Okay, nitrate. So here the nitrate is simple anion, here there is no simple cation, and this is the coordination sphere. In this example, you have to write the name of the coordination sphere. In that, first you have to write the metal, that is platinum, and 2 types of ligands are there. One is chlorido ligand and ethane 1,2-diamine. Here dichlorido, that means Cl2, and bis ethane 1,2-diamine. Ethane 1,2-diamine means En. How many ethane 1,2-diamines are there? Here bis is given, therefore it is 2. This is the coordination sphere. Now you have to write the simple anion, that is nitrate, that is NO3. We know that NO3 will be having minus charge on it. Okay, the oxidation state of platinum is +4, and here the charge on Cl will be -1. -1 into 2, it is -2. The charge on ethane 1,2-diamine is 0 because it is a neutral ligand. Therefore, the charge on the coordination pair is what? +4 -2. Therefore, it is +2. The charge of the cation should be equal to the charge of the anion. Therefore, we know that NO3 will be having minus charge. If there is NO3 twice, gives you -2. So, if you rewrite that, platinum Cl2 En twice, NO3 twice. Okay, this is how you have to find out the formula. This is all about IUPAC nomenclature of coordination compounds. If you found this video helpful, do like, share and subscribe. Thank you for watching.